You scrub it on a Sunday afternoon. Bleach spray, an old toothbrush, 30 minutes on your knees pressing into grout lines until your fingers are raw, and it looks clean. It genuinely looks clean. You rinse it, you dry it, you step back, and it looks good. 3 weeks later, the black is back. Not in a different spot. In the exact same spot, the exact same grout line, the exact same corner of cork, the exact same ceiling seam above the shower where the paint is starting to bubble. You could trace the outline with your eyes closed because you've been staring at it for years. You've tried the bleach pen. You've tried the tea tree spray. You've tried the ventilation fan you installed 2 summers ago that made absolutely no difference. You've tried leaving the shower door open to dry it faster, which your partner hates. You've tried the mold-resistant paint that the guy at the hardware store swore by, and 8 months later it was worse than before the paint because the mold had something new to eat. Here's what nobody told you. You are not losing a cleaning battle. You are losing a biology battle. And the reason bleach never wins is that bleach doesn't understand what mold actually is. I want to show you something that changed how I think about this completely, and it starts with a piece of copper wire you can buy at any hardware store for about $4, and a set of findings from a 1973 research review at Battelle Columbus Laboratories that looked at 312 separate scientific citations on the antimicrobial properties of copper going all the way back to 1892. 130 years of scientific observation. And at the end of this video, I'll tell you about a specific installation approach that combines what the research says with what I've seen work in real bathrooms, including my own, and why it works even when everything else has failed. But first, I need to tell you the thing that the bleach bottle companies have every financial reason to keep you from knowing. The mold in your bathroom is not dirty, it is alive. That sounds obvious, but it changes everything about how you fight it. Cladosporium, Aspergillus, Penicillium, or Rheobasidium. Those are the 4 most common mold genera found in bathroom environments, and they are not stains. They are colonies. They are living organisms with root structures called hyphae that penetrate porous surfaces like grout and silicone cork at a microscopic level, going deeper than any bleach solution can reach. When you spray bleach on bathroom mold, the sodium hypochlorite oxidizes the surface pigment. The colony turns white. The surface looks clean. But the root system underneath is intact, and within 2 to 3 weeks, the colony has regrown from the same root structure in the same spot, using the same biological machinery it has always used. Bleach, if we're being precise about this, whitens mold. It does not kill it at depth. This is why the problem comes back to the exact same location every single time. The surface is clean, and the biology is untouched. The mold does not care about your cleaning schedule. It cares about one thing: moisture. At relative humidity above 60%, most common bathroom mold species begin active growth within 24 to 48 hours of landing on a suitable surface. The average bathroom after a hot shower hits 80 to 90% relative humidity. It can take 2 to 4 hours for that humidity to drop back below the growth threshold, even with a ventilation fan running. During every single one of those hours, every spore that landed on your grout while you were showering is already beginning the process of sending out hyphae, finding purchase, beginning to colonize. You are not dealing with a dirty bathroom. You are dealing with a biology that has evolved to exploit exactly the conditions your bathroom creates every morning. This is why the solution is not cleaner. It is not stronger chemicals. It is not more scrubbing. The solution operates at a different level entirely, and it has been understood by materials scientists for well over a century, long before the antifungal spray industry existed to make money selling you a bottle every 3 weeks. The oligodynamic effect. Remember that phrase. In 1893, a Swiss botanist named Carl Wilhelm von Nageli observed something strange. Metal ions, even in extremely small concentrations, were lethal to microorganisms, not merely slowing their growth, lethal. He called this the oligodynamic effect, from the Greek oligos, meaning few, and dynamis, meaning power. The power of very few particles to do very large biological damage. The metals he studied included silver, mercury, zinc, and copper. Copper, it turned out, was among the most effective and also among the safest for human contact. And what von Nageli had identified was not a chemical trick or a synthetic invention. It was a natural property of the metal itself, one that operates continuously, passively, and without requiring any human action to initiate. Here is the mechanism, because the mechanism is the whole point. Copper is a transition metal with two oxidation states, copper 1+ and copper 2+. At the surface of any copper object, a slow, continuous reaction with moisture in the surrounding air and on surrounding surfaces causes copper atoms to release ions. These ions, the Q2+ variety in particular, are extraordinarily reactive. When they come into contact with a fungal cell, they penetrate the cell membrane. Inside the cell, they trigger the production of what chemists call reactive oxygen species, essentially the same chemistry that happens when hydrogen peroxide bubbles on a wound. These reactive oxygen species rip apart the cell's internal machinery. They shred the DNA, they disrupt the membranes, they halt enzymatic processes that the cell cannot survive without, and the fungal cell dies. This is not a slow process. On bare copper surfaces, studies have documented the death of microbial cells within minutes to hours of contact. And the critical word here is contact. The copper does not need to be touching the mold directly to release ions into the surrounding environment. In a moist, enclosed space like a bathroom, ionic copper disperses through humidity, through condensation on surfaces, through water films on tile and grout. The metal becomes, in effect, a continuous, low-level antimicrobial presence that does not switch off, does not need reapplication, and does not lose efficacy over time. The 1973 Battelle-Columbus Laboratories review I mentioned at the beginning compiled 31 scientific citations on this exact phenomenon, covering the period from 1892 to 1973. 80 years of copper antimicrobial research that existed before the modern antifungal product industry was even a significant market. Their conclusion, which appears in peer-reviewed literature, was that copper, in very small quantities, has the power to control a wide range of molds, fungi, algae, and harmful microbes. The specific mold species they documented copper killing included Aspergillus niger, the same Aspergillus that is sitting in your grout right now. Why does humidity make copper more effective, not less? This is the part that surprised me the most when I went deep into the research, because intuitively you would think that a wet bathroom would wash the copper effect away. But the biology works the other way. Copper's antimicrobial action depends on ion release, and ion release accelerates in the presence of moisture. A dry copper surface in a dry room releases ions relatively slowly. A copper surface in a high humidity environment releases ions continuously and at higher concentrations because the water molecules act as the medium through which ionic copper travels. A 2009 study published in peer-reviewed literature and later referenced in an NI-indexed analysis specifically examined the performance of copper alloys against MRSA at varying temperatures and humidity levels. Their finding was striking. Copper alloys demonstrated greater than 5 log reductions in bacterial viability, which means killing 99.999% of the target organism under all test conditions, including the temperature and humidity levels typical of indoor environments. The researchers concluded that this outcome favors the use of copper alloys as antimicrobial materials in indoor environments, such as hospitals. Read that sentence again. Hospital administrators are already using this. Copper door handles, copper bed rails, copper bathroom fixtures. Not as decoration, as infection control. The research backing this decision is extensive, peer-reviewed, and entirely accessible if you know where to look. Your bathroom is exactly the environment where copper performs best, because the humidity is high, the surfaces stay moist, and the conditions for ionic copper dispersal are optimal. The thing that makes mold thrive in your bathroom is the same thing that makes copper maximally effective in your bathroom. You just need to get the copper into the space. The copper wire installation, exactly how it works. A single length of solid copper wire, the type sold in hardware stores as electrical grounding wire or craft wire, 12 or 14 gauge, creates a continuously active ionization field in any enclosed space it occupies. It does not need to be connected to anything. It does not need a power source. The ionization happens through simple electrochemical reaction with moisture in the air. Here is the specific approach that I have found to work, and that is consistent with the underlying science. You take a length of solid copper wire, not stranded, not coated, solid uninsulated copper, and you stretch it horizontally across the upper section of your shower or bathroom enclosure, not touching the wall. Suspended across 2 anchor points, small cup hooks or corrosion-resistant screws work well, positioned near the ceiling line or just below the highest point where condensation collects. That location matters. Condensation forms first at the coolest surface in a room. In a bathroom, that is typically the ceiling and upper wall area. That is also, not coincidentally, where mold establishes itself most persistently. You are placing the copper at the origin point of the moisture, where the conditions for ion dispersal are optimal. You do not need a lot of it. A single 12-gauge wire stretched across a standard shower enclosure, maybe 36 to 48 inches of wire with the surface exposed to the humid air, is sufficient to begin releasing copper ions into the enclosed atmosphere. In a small, enclosed shower stall, that ionic concentration builds over time. Mold spores landing on treated surfaces find an environment hostile to establishment. The hyphae that try to penetrate grout encounter ionic copper in the water films on porous surfaces. The colonization process gets interrupted at the cellular level before the colony has a chance to take hold. You can extend the installation. A second wire along the lower shower wall. Copper staples pressed into grout lines along the most persistently affected areas. A short coil of copper wire placed in the corner of the bathroom floor near the drain, where standing water collects. Each additional piece of copper expands the ionic field. More surface area, more ion release, more continuous antimicrobial presence. The total cost for a complete bathroom installation runs between $4 and $12 depending on wire gauge and the amount of wire you use. The research on copper in enclosed, humid environments. What the HVAC studies tell us. The Department of Defense funded research examining whether replacing aluminum and steel components in military HVAC systems with copper could control microbial growth in the moisture-rich environments inside those systems. HVAC heat exchangers are exactly the kind of enclosed, perpetually damp, poorly ventilated space that mold loves. The study at a full-scale HVAC system using copper versus aluminum heat exchangers measured resident bacterial and fungal populations over a period of 30 weeks. The copper exchangers showed dramatically lower colonization rates throughout the study period. The International Copper Association summarized the conclusion of that research line this way: copper-coiled units are virtually mold-free even after years of use. Years of use. Not years if you maintain the copper, not years if you reapply something. Just years, because the copper remains active without any human intervention. This is the fundamental difference between copper-based antimicrobial function and every product under your bathroom sink right now. The spray bottle has a finite dose. It depletes. It needs to be purchased again. The copper does not deplete. It oxidizes slowly over time, and as it oxidizes, it releases more ions. An older piece of copper in a bathroom is in some ways more antimicrobially active than a brand new piece because the surface patina increases the effective reactive surface area. The British Royal Navy understood this. In 1761, the Admiralty sheathed the hull of the frigate Alarm in copper. The goal was to prevent marine organisms from colonizing the wooden hull. It worked so effectively that within a few years most of the fleet had copper-sheathed bottoms. The Navy was not trying to discover a cleaning product. They were using the oligodynamic effect, centuries before von Nägeli gave it a name, to create an inhospitable surface for biological colonization. The same principle, the same metal, the same mechanism. Apply it now to your grout lines instead of the keel of a warship. The disappearance from mainstream advice. Why you have never heard this. The antifungal product market in the United States generates over $1 billion annually. Bathroom mold removers, mold-resistant paints, antifungal caulk, spray sealants, grout cleaners with antimicrobial additives. Each of these products has a finite lifespan by design. The spray runs out. The paint loses its additive over time. The caulk degrades and must be replaced. The consumer returns to the store. The cycle continues. Copper wire does not require this cycle. A $4 piece of hardware wire lasts indefinitely in a bathroom environment. It does not go in a recycling bin. It does not run out. It does not need to be restocked. There is no recurring revenue model attached to it. The scientific literature documenting copper's antimicrobial effectiveness is not hidden. It is publicly available, peer-reviewed, indexed in the National Library of Medicine, referenced by the EPA, studied by universities, and applied in hospital infection control programs around the world. It simply does not get mentioned in the context of the average homeowner's bathroom because there is no commercial infrastructure that benefits from that mention. Think about the last time you walked through the bathroom cleaning aisle of a hardware store and saw copper wire displayed alongside the mold removers with a placard explaining the oligodynamic effect. That placard does not exist, not because the science doesn't support it, because the science supports a one-time $4 purchase instead of a recurring $15 spray purchase. This is not a conspiracy. It is just an accurate description of how product markets work. Research that supports a repeat purchase product gets funded, promoted, and placed on shelves. Research that supports a one-time passive material does not have a commercial sponsor to carry it from the scientific literature into the home improvement aisle. The specific mold species in your bathroom and why copper addresses each of them. Let me be precise, because the specific biology matters. Cladosporium is the most common bathroom mold, the dark green to black fuzzy growth you see on grout and around cork. It thrives at temperatures between 18 and 28 degrees Celsius, which is exactly the range of a typical bathroom after a shower. It spreads through airborne spores that are small enough to travel on air currents created by the shower itself. Copper ions disrupt the enzymatic processes Cladosporium uses for spore germination. Spores that land in an ionic copper environment cannot complete the germination phase. The colony never establishes. Aspergillus niger produces the black circular patches you see on bathroom ceilings and on the upper sections of tile walls. It is a particularly tenacious species because it produces a thick outer cell wall that resists many surface-applied chemical treatments. Copper ions, however, enter through a different mechanism, disrupting internal cellular chemistry rather than attacking the outer wall directly. The Battelle review specifically documented copper inhibiting Aspergillus niger. So did a peer-reviewed comparison of antifungal efficacy of copper versus aluminum surfaces, which found dramatically increased die-off of fungal spores on copper surfaces compared to aluminum. Penicillium produces the blue-green powdery patches you sometimes see on damp bathroom walls or on the backs of shower curtains. It is related to the mold from which the antibiotic penicillin was derived, which means it is, ironically, quite resistant to many antimicrobial compounds. Copper ions disrupt its cellular membrane in a way that does not trigger the resistance mechanisms it uses against antibiotic-class compounds. The Battelle review documented copper inhibiting Penicillium chrysogenum specifically. Aureobasidium, sometimes called pink mold because of the distinctive pinkish-orange slime it produces on grout and cork before maturing into darker growth, is particularly associated with the interface between tile and silicon cork. It produces biofilms, sticky matrices of living cells, and secreted material that are mechanically resistant to scrubbing. Ionic copper penetrates biofilms by traveling through the water channels within the biofilm matrix. The copper does not need to reach the surface. The ions move through the moisture that the biofilm itself contains. One copper wire addresses all 4 species simultaneously because it operates at the ionic level, which is below the level at which species-specific resistance mechanisms function. This is different from how most antifungal products work, which is why you do not have to rotate copper the way you rotate pesticides or worry about the mold in your bathroom developing resistance. Mold cannot evolve a mechanism to resist copper ions, the way it can evolve resistance to a synthetic chemical compound, because copper ions disrupt fundamental cellular chemistry that the cell cannot function without. The setup in full. What to buy, where to put it, what to expect from any hardware store. Solid, uninsulated copper wire, 12 or 14 gauge, sold in the electrical section. You want solid, not stranded, because solid wire has more surface area in contact with the air per unit of length. Stranded wire works too, but less efficiently. Budget about $4 to $8. 2 small corrosion-resistant cup hooks or stainless steel screws. These go into the wall at the highest point of your shower enclosure or bathroom, where you can anchor a horizontal wire run. If your shower has a glass enclosure with metal rails, you can loop the wire around the rail hardware. The wire does not need to be under tension, it just needs to be suspended in the space, not lying flat against a surface. The wire should be positioned at the upper third of the shower space. This is where condensation forms first, and where airborne spores concentrate because warm, moist air rises. You are placing the copper where the biology is most active. For maximum effect, add a second run of wire at about knee height inside the shower, again horizontal, positioned along the wall where mold most consistently appears. This creates a layered ionic field across the full vertical height of the shower enclosure. For the grout lines that have the worst persistent mold, you can press small pieces of copper wire directly into the grout joint using a thin tool. The wire sits in the grout channel. The surface remains exposed. That grout line now releases copper ions directly into the porous material where the mold root system lives. Clean the existing mold before installing the wire. Not because the wire cannot address active colonies, it can and does, but because removing the surface biomass gives the copper a cleaner starting environment and you will see results faster. Use whatever you have for that initial clean. After installation, the copper handles the prevention. What to expect in the first 4 weeks. Mold growth rate slows. The black lines that used to reappear within 2 to 3 weeks after cleaning begin taking 4 to 6 to 8 weeks before they reappear, and when they do reappear, they are lighter and less extensive. Within 3 to 6 months of continuous copper presence in the space, most people find that they have essentially no new mold establishment in the shower area. The grout lines stay clean between cleanings in a way they never did before. The ceiling stays clear. The cork stays white. The effect compounds over time because the copper slowly releases ions into the grout itself, building up a trace mineral presence in the porous material that makes it progressively less hospitable to mold root systems. You are not just clearing the surface. You are, over months and years, chemically altering the environment that mold has exploited. The hospital plumbing evidence. The most compelling real-world proof. Hospital water systems contain a pathogen called Legionella pneumophila, which causes Legionnaire's disease. It thrives in the warm, moist, enclosed environments of building plumbing systems, which is why hospitals have an ongoing and serious problem controlling it in their water distribution infrastructure. A documented approach to Legionella control in hospital plumbing systems is copper-silver ionization, in which copper and silver ions are introduced into the water supply at low concentrations to create a continuous antimicrobial environment throughout the pipe network. The first 16 hospitals to adopt copper-silver ionization for Legionella control documented their experiences in a study that assessed the implications of this approach for evaluating other disinfection modalities. The results were positive enough that the approach spread widely through hospital infection control practice. The mechanism is the same oligodynamic effect we have been discussing. Copper ions in the water. Ionic copper disrupting microbial cellular function. The difference between your bathroom and a hospital plumbing system is scale, not principle. The hospitals were applying at industrial scale the same antimicrobial chemistry that a $4 piece of copper wire provides passively in your shower enclosure. The fact that hospitals use ionized copper to control dangerous waterborne pathogens in enclosed, moist environments is documented in the peer-reviewed medical literature and referenced by major research institutions. That same ionic mechanism in a bathroom controls the mold species that have been colonizing your grout for the last 3 years. The biology does not change because the setting is different. Why this does not work for everyone who tries it halfway. There are 2 mistakes that undermine the copper wire approach and produce disappointing results. The first is using coated or stranded wire. Any coating on the wire, plastic insulation, rubber jacketing, a lacquer or paint finish, blocks ion release entirely. The copper has to be bare metal in contact with the air. Stranded wire has the individual filaments bundled together, which dramatically reduces the exposed surface area. Solid, uninsulated wire is the specification that matters. The second mistake is placing the wire flat against a wall or surface. The copper needs to be suspended in the airspace of the bathroom to release ions into the humid air. Pressed flat against tile, the ion release goes into the tile surface where it is less useful. Suspended in space, the ions travel through the moisture in the air and reach surfaces throughout the enclosed volume. People who try the approach with coated wire or with the wire lying on a shelf report little to no effect. People who follow the suspension method with bare solid wire report dramatic reductions in mold recurrence within 2 to 3 months. The difference is not the copper. The difference is whether the copper is actually able to do the thing that copper does, the full picture. What you are actually building. When you hang a copper wire in your shower, you are not adding a cleaning product. You are not adding something you will eventually have to replace. You are adding a passive, continuous, chemically active antimicrobial presence that operates 24 hours a day, every day, without any maintenance, without any reapplication, without any recurring cost. The mold in your bathroom is not a hygiene failure. It is a biology operating according to its own rules, finding moisture and establishing colonies in porous surfaces with mechanical persistence that no scrubbing cycle can overcome. The wire changes the environmental chemistry of the space in a way that mold's biology cannot adapt to. It disrupts fungal cellular function at a fundamental enough level that resistance does not develop the way it does against synthetic antifungal compounds. The research supporting this is not fringe, it is not alternative. It is indexed in the National Institutes of Health database. It is applied in hospital infection control programs. It was documented in The scientific citations going back to 1892. The EPA has recognized copper as an antimicrobial material effective against a documented list of pathogens. The mechanism has a scientific name, the oligodynamic effect, coined 130 years ago, and the science behind it has only gotten more precise and more thoroughly confirmed in the century since. You have been losing a biology battle with a cleaning product. A $4 piece of wire is a different kind of tool entirely. It is not competing with bleach in the cleaning aisle. It is operating at a completely different level, which is why it produces a completely different result. Before I close, I want to address the comment I already know is coming. Someone is going to say, "This sounds too simple," that if this worked, everyone would already be doing it. I want you to think carefully about that objection, because it assumes that product markets efficiently deliver the most effective solutions to consumers. They do not. They deliver the most profitable solutions. A one-time $4 purchase is not profitable. A bi-weekly spray bottle at $15 a unit is. The copper wire approach is not unknown because the science does not support it. The science is abundant and peer-reviewed and publicly accessible. It is unknown in mainstream home improvement conversations because no marketing budget benefits from it being known. That is the honest answer. And once you see the results in your own bathroom, which you will within the first couple of months, it will be the answer you give when your neighbor asks why your shower grout finally looks clean. Tell me in the comments, what is the single spot in your bathroom where mold always comes back no matter what you do? The corner of the cork at the tub? The ceiling above the shower? The grout on the back wall? I want to know where the persistent spots are because the next video goes into specific placement strategies for different bathroom configurations and different mold species, and the comments are how I know what to focus on. Subscribe so you see it when it goes up. What is coming next makes this look like the introduction.